Hi, so in today's lesson, we are going to be learning how to use the formulas we looked at in previous video, the equations of motion formulas that we looked at in the previous video. I'm going to be using that to solve series of examples. Now, look at this example. A car moved from rest. From rest means that initial speed, that means initially it was not moving, the speed was 0. Initial. And remember that initial velocity or initial speed represented as u. Then u has to be 0 meters per second. That means it's not moving at rest. Then acceleration is what? 0.2 meters per second squared. And it has to find its velocity when. So that's final. V equals, we don't know. When it has moved a distance of what? 50 meters. Now, no time given. We just have 4 UAVs. Which of those three formulas have U? So let me just list them out. V equals U plus AT. That's how you're going to do it. So list out the formula. S equals to UT plus half AT squared. And V squared equals to U squared plus 2AS. So which of these three formulas can I use? U is here, A is here, V is here, but we don't have a T. We are looking for V, but we don't have a S, so we can't use that. So S, we have a S here. Good. We have a U. We have a T. No, we don't have a T, so we can't use this. Besides, we don't have a V in this question. We're looking for V, so we can't use this formula. Cancelled. Okay. So that means the only option that we have now is the third one. So V is what we're looking for. V squared equals to U. What's our U? 0 plus 2 times, oh, so I'm writing G is A. Sorry. What's my acceleration? 0.2 times, what's my S? My S is 50. Okay, good. Then I can say V squared now becomes 0 plus 2 times, this is actually 1 over 4. Oh, sorry, 2 over 10. Oh, that's 1 over 5. Yep. 1 over 5 multiplied by 50. Then 5 here 1, 5 here 10. And that gives me V squared equals to 20. 2 times 10 is 20. Then square root both sides. Square cancels out square. V equals to square root of 20. Square root of 20 is actually 4.47 meters per second. So this is the V for that question. That's the answer to the question. So let's take another example. So here we have this example. If a car moves from rest, starting position is rest. So therefore, U has to be 0 meters per second. So you have to be familiar with all of these terminologies. Rest means initial velocity 0. With an acceleration, A equals 2 meters per second squared. Time after 5 minutes, T equals 5 minutes. Now the question is, how far has the car traveled? Well, they're asking for exactly distance S. Okay. Now list out your three equations of motion. U equals to U plus AT. S equals UT plus half AT squared. And V squared equals to U squared plus 2AS. Okay, so which of the formulas am I going to use? I have UATS. So which of them am I going to use? This? Nope, because there's no even S here. Here, probably we have a U, we have a T, we have a A, we have a T. Okay, so we're going to use that. Okay, so we're using this S equals to UT plus half AT squared. So what's my S? That's what we're looking for. What's my U? 0 times 5 minutes. But you have to convert this. This is in seconds, this is in seconds, so your time also has to be in seconds. So I'm going to convert this to, how many minutes make 1 second? Exactly. 60 minutes make 1 second. So that'll be 5 times 60 seconds. So that's about 300 seconds. Okay, good. So that's about times 60. Okay. Then plus half times, what's my A? My A is 2 meters per second. 2, then my T is actually 5 times 60 is actually 300. 300 squared. Okay. All right. So let's calculate. So I have S becomes, all of this is 0, half multiplied by 2, then multiplied by 300 squared. This cancels this, and so I have 300. S equals to 300 squared. What's 300 squared? 300 squared is about 90,000, if I'm not mistaken. Yes, 19,000. That's S equals to 90,000 meters. Can I convert that to kilometers? Of course, I can leave my answer like this, but can I convert it to kilometers? Yes. So divide by 1,000. Kilo means 1,000. So 1,000, 3 zeros, 3 zeros. So I'm left with 90 kilometers. So that's the distance. The distance is actually 90 kilometers. All right, good. So let's take one more example before we end this video lesson. So we have this example. A car has a uniform velocity of 108 kilometers per hour. So when you hear the word uniform velocity, what they are telling you is that the initial velocity, what they are saying, the initial velocity u is the same as the final velocity v. That's what they are saying, uniform velocity. And that is also equals to 108 kilometers per hour. Now, then how far? They're asking for distance. Does it travel in half minute? T is half minute. So now, the units are not exactly the same, so I have to convert this to meters per second, and I have to convert this back to second as well. So how do I do that? How do I do this? So what this means is that I have 108 kilometers per hour, right? Every 1 hour. That's what it means. So convert kilometers, so I convert it to meters per second. So to convert that, I'm going to convert this to meters. Since it's kilo, it's going to be 1,000 divided by 60 seconds make 1 minute. 60 minutes make 1 hour. So that'll be 60 seconds make 1 minute, and 60 minutes make 1 hour. So that's 60 by 60. So definitely I just have 108, 123, and then divided by 6 times 6 is 36, 0, 0. Okay, so 0, 2 zeros will cancel out this, and I have 1080 divided by 36. What I get is 30. So I'm getting 30 meters per second. So what they're saying is that u equals to v, and that's 30 meters per second. So what's half of a minute? Half of a minute is 30 seconds, because 1 minute is 60 seconds. So this is actually 30 seconds. Okay, so now we just have two things. We have u equals v. Okay, we've written that before. And we have time equals 30 seconds. We have to calculate distance. So of the three equations of motion, which are we going to use? V equals u plus at, s equals to ut plus half at squared, and v squared equals to u squared plus 2as. Which one of them do you think is appropriate? We have u, we have v. We have u, we have v, we have a, we have no, we don't have a, and we don't have t. So first formula is gone. S, we have to calculate S. We have U, we have T, we have half, but we don't have A. We don't have A. So what do we do? But A is in all the formulas. So what should we do? Did you give us A? In the question, did we have? We don't have A. We don't have A. So what should we do? Now let's go back to the question. Okay? I think that'll be better. Let's say a car has a uniform velocity. That means the initial and the final velocity is the same. So if the initial and the final velocity is the same, that means there is no acceleration. The acceleration is equal to 0. So that means they are not accelerating, since the difference between the initial speed or velocity and the final velocity is actually the same, so there's no acceleration. So you have to take note of those very slight things. So acceleration is actually equals to 0. Okay, so that means we can use this because we have our t and we have our a now. Okay, so s now becomes u. What are u? Our u is 30 times, what's our t? 30 seconds plus half times a 0 multiplied by 30 squared. So because of 0 multiplied by anything, so all of this is actually automatically 0. So I have my distance is equals to 30 times 30, and 30 times 30 is actually 9. That's 900 meters. So can I convert this to kilometers? Yes. How do I do that? Divide that by 1000. So this divided by 1000, I have 0.9 kilometers. So that's my distance. So you have to be very careful when you're solving equations of motion problem, because you have to take note of the word. You see, the uniform velocity means that acceleration is actually equals to 0, and that the initial speed or velocity is the same as the final velocity. All right, and when object is at rest, their initial velocity is actually 0. So let's take note of that. So in the next subsequent videos, we'll be taking more complex questions on equation of motion. Watch out.